Hello, welcome to news tutorial presented by the SHLDB on Redox Reaction with reference Cambridge International AS by Lori Ryan and Roger Norris. So, here is a redox reaction. So, redox reaction, we need to know the learning outcome. Calculate the oxidation number of elements of compounds and ion. Describe and explain redox processes in terms of electron transfer and change in oxidation number, and use the changes in oxidation number to help balance the chemical reaction. So what's a redox reaction? In a redox reaction, what is a redox reaction actually? So when you hear the word redox, it means that reduction and oxidation, addition. So what's a redox reaction? A redox reaction is a reaction whereby one species is being oxidized while another is being reduced in the same reaction. That's a redox reaction. Now, there's a difference between a redox reaction and a disproportionate reaction. What's a disproportionate reaction? A disproportionate reaction is a reaction in which one species is oxidized and that same species is being reduced in the reaction. So that's the difference between a redox reaction and a disproportionate reaction. So now let's see now, in this case you have this species is being oxidized. This is a redox reaction. This is actually only oxidation. So when you want to see redox reaction, you need to define again two main terms: what is oxidation and what is reduction. Oxidation has three definitions. The first one is a gain of oxygen, is a loss of hydrogen and the loss of electron. That's oxidation. Now, what is reduction? Reduction has also three definitions, which is the gain of hydrogen, the loss of oxygen, and the gain of electron. So these are the two main definitions, the three definitions of each of them. So now in this case, when you have this reaction here, so in this reaction here you have the oxidation of hydrogen and you have the reduction of lead. So this is what have occurred in this question, and these are other examples. So now these are the different oxidation. We say that the loss of electron, reduction, gain of electron. So half equation that we have. So these are the different points to put in mind. So now how do you balance a half equation? So in order for you to balance a total equation, a total redox equation, we need to first balance the half equation by knowing their half equations. So example, when you have this equation, let's say the total equation of this reaction is going to be this, and you are being asked to balance this equation. In order to balance this equation, you need first to convert them into half equations as such here. So when you convert them into this half equation, you are going to have nickel converting to this and iron convert to this. When you have this, you are going to balance when you want to balance each half equation, you balance according to the number of electrons, and you also balance according to the number of atoms. So you see that nickel here has only one atom. Here nickel has only one atom. It's okay. Now you need to add two electrons here on this side in order to have in order for it to be balanced both atomically and charged. So now when you have balanced this above equation, now you now multiply this lower equation now by 2, the number of electrons which are above here. So I multiply here by 2, I multiply by 2, I multiply by 2. So when I multiply by 2, I will see that there's 2 electrons which will be on the reactant side, and 2 electrons will be on the product side. And I'll sum up the equation, and then I'm going to have nickel plus 2 iron 3 iron to give this. I'll cancel up the 2 electrons on both sides of the equation because they are on both sides, so there's no need. So now this is another equation. So let's say that you are being given the full equation as well, and you are asked to balance the equation. The first thing to do is to put them into their half equations. The half equation are going to be iodide to give iron and this iodine plus 2 electrons. You are going to try to balance it both going to balance it both atomically and by charge. So when I add 2 electrons here, actually I'm going to have 2 iodide ions. So now the next thing is also to have manganate plus 8 electrons plus that. So this, you see that 5 electrons are on this side. In order for me to have a common number of electrons on this side and this side, I will multiply here by 5 and I'll multiply here by 2. So here finally I'm going to have 10 iodide, I'm going to have 5 iodine, I'm going to have 10 electrons here, and here I'm going to have 5, here I'm going to have 5 times 5 times this, so multiply it by 2, 5 times 8 actually is going to give, so I multiply it by 2 is 5, 2 times 8 gives 16, then I multiply it by 2, they gives 10, I multiply it by 2, so the sum is going to give you 2 manganate ion plus 10 iodide plus 16 hydrogen plus 2 manganese plus all that. So this is how to balance your half cell. The next point in this part of redox reaction is to find the oxidation number. In order to find the oxidation number of a certain atom, we need to first know the oxidation number of the various the exact oxidation number of the various different atoms. There are different oxidation number which are given to known metals according to the different groups that one element accounts to. Example, group 1 element are given usually oxidation number of +1. Group 2 are given oxidation number of +2. But you need to know that oxidation number can vary mostly according to group 3, group 4, and group 5 element. But for group 1, group 2, group 6, group 7, and group 8, the oxidation number are usually constant and they are not changing. So group 1 +1, group 2 +2, fluorine -1, hydrogen you have +1. So all that you have different oxidation number, that the oxidation number are known. So example, if you have a certain element like iodide trichloride as such, here you have chlorine as oxidation number of -1. So in order to do this, you say just X is equals to you say that the oxidation number, you see that the total oxidation here is going to be 0 because it's electrically neutral. So you say that X plus 3 into -1 is going to be equals to 0 actually. So since equals to 0, you say that so it's going to X minus 3 is equals to 0. I'll bring 3 to the other side, then my answer of oxidation number of iodide is going to be +3. This is how to calculate it as easy as possible. So you can also have compound ions like sulfur. Here oxygen is going to be -2. You just say here the total ions is going to be -1. So you say X plus, so you have X here plus 3 into -2 because of oxidation number of oxygen is equals to -1. So 3 times -2 gives -6. I bring it on other side, I have -1 plus 6. So -1 plus 6 gives 5. So in this case, the oxidation number of nitrogen is going to be +5. So these are the different values you have. So these are the different points, and you can also have the naming of compounds. Here, in order to name them, you just name it according to your oxidation number. Here, example, iron 2 chloride with oxidation number of 2, iron 3 chloride oxidation number of 3. So this is as easy as possible. So these are the different points that you were supposed to note in redox reaction. So say thanks for your kind attention, and please don't forget to like and subscribe for the channel. Thank you.